Hello guys, so welcome to Nisike Academia. If you've not subscribed to this channel, do well to hit the subscribe button as soon as possible so you'll be able to get notifications whenever subsequent videos drops. Okay, so in this class we are going to be looking at vectors, and of course from elementary physics we have two major classes of quantities. Okay, when it comes to their measurement and of course the level at which they operate. Okay, so these quantities are of course divided into what we call scalar quantities and vector quantities. Scalar and vector. All right, so scalar quantities are quantities that have magnitude but no direction. They have magnitude but they don't have any direction. Okay, when we talk about magnitude, it's more like the mass content of these quantities, more like the spatial representation of this quantity, or should I say spatial representation of these quantities, more like when you say an object has a particular mass, the wideness, the um surface area that it occupies, but if you look at it, it does not move in any particular direction. Okay, just like a human walking from, let's say, point A to point B, but do not have a direction. It's just diverting and moving aimlessly. Okay, so scalar quantities do not have direction, but they have magnitude. But on the other hand, the vector quantities have both magnitude and they also move in a specified direction. Examples of vector quantities of which we'll be looking at. Examples we have displacement, we have displacement, we have velocity, we have weight as well. Acceleration is also an example of vector quantities. We also have force. Force is a typical example as well. Okay. We have impulse. We have pressure. We have momentum. We have gravity. Now, etc. Now, these are examples of vector quantities. And remember, don't forget that vector quantities are quantities that have magnitude and also direction. So in our class today, we are going to be looking at addition and subtraction of vectors. Okay, that's the first part. The second part will be vector products, which is divided into dot products and cross products. Dot products are also called scalar products. Cross products are also called vector products. We're going to look at how to calculate the magnitude of vectors. We're also going to look at how to determine the angles across vectors, or angles that are formed between vectors. So these are the crucial aspects of vectors that you are expected to familiarize yourself with, okay, at the elementary level of the study of vectors. Okay, so first of all, we'll look at addition and subtraction of vectors. Addition and subtraction of vectors. All right. So basically, when we talk about vectors, we have what we call vector units. Okay, vector units or unit vectors. Unit vectors. When we say vectors, we are talking about what we call I, vector unit I, vector unit j, and vector unit k. Now this arrow at the top that is pointing rightwards is basically explaining the fact that it is moving in a particular direction. All right, moving in a particular direction. So we have these unit vectors as ijk. So you can have a vector set as, for instance, x. Most times variables are used to represent vector sets. You can have x to be, let's say, 2i plus 3j minus 4k. Then you can have another vector set to be y, so let's say I minus 2j minus 9k. These are vector sets. This set x, this vector x, have I, j, k. All right. Vector y also have I, j, and k. All right. So it's very important for you to understand that these vectors must have their unit vectors in them. We can also have A and B. We can have C and D. You can have vector A to be, let's say, 4i minus 3j minus k, or you can have vector B to be, let's say, 7i plus 3j minus 2k. It can be C and D. It can be E and F. You understand? Any letter can actually be used to represent a particular vector set. But one thing you need to know is that the unit vectors must be I, J, and K. So now let's delve basically into the addition and subtraction of vectors. So now let's look at this. Let's say we have given two vectors. Let's say we are given two vectors, vector A to be 6i minus 3j plus 2k, and vector B to be, let's say, okay, so let's say we have minus 2i plus 9j minus 3k. All right, these are two sets of vectors, and we are told to find a plus b. That's a plus b, let's say 2a minus 3b. Then c, let's say we have minus 4a plus b. Then d, let's say we have 2a plus 3b. All right, 2a plus 3b. So now how do we navigate through this? All right, how do we navigate through this? Let's begin with a plus b. Let's begin with a plus b. So now basically, when we are looking at addition and subtraction of vectors, we are focusing majorly on adding and subtracting the like terms. Okay, so but this is how we do it. Look at a here. We have to bring out vector A, which is 6i minus 3j plus 2k. What's the sign after vector A? Plus, right? Then now open bracket and put your vector B, which is minus 2i plus 9j minus 3k. Close the brackets. All right, close the brackets. Then what you have to do now, you have to open the bracket and collect like terms. So this will be 6i minus 3j plus 2k, plus times minus. Now take note of these identities. Plus times minus is minus, minus times plus is also minus, plus times plus is plus, while minus times minus is plus as well. Take note of those identities, all right, because we are going to be applying it a lot here. So now plus times minus is minus, so this is like plus minus, which is minus, so we have minus 2i, plus plus is also plus, which is plus 9j, plus times minus is minus, which is minus 3k. So what I want to do is collect our like terms. So collecting like terms is to add or subtract like terms. When I say like terms, I'm talking about terms that have I, okay, terms that have j, terms that have k. You would only relate a term that have I with I, a term that have j with j, and a term that has k with k. Is that clear? So now we say 6i minus 2i. This will give us 6 minus 2 is 4. So this will give us 4i. Minus 3j plus 9j. Minus 3, just assuming you're owing 3. Plus 9, you have 9. Minus 3 plus 9 is different from minus times plus, please. This has to do with directed numbers. Now, this particular one has to do with multiplication of signs. Please try and differentiate it. If there's a difference between minus 2 minus 9 and let's say minus 2 times minus 9, they are different. Minus 2 minus 9 means that you're owing 2 and you're owing 9, which means you'll be owing 11. Minus 2 times minus 9, this is when you apply that minus times minus plus. So plus 2 times 9 will give you 18. Are you seeing the difference now? All right, there's very clear difference. The difference between let's say minus 2 plus 9 and minus 2 times 9. Minus 2 plus 9 is you're owing 2, then you have 9. By the time you pay that 2 that you're owing, you have 7. So it's plus 7 or just 7. Why minus 2 times 9 is minus 18. All right, because this 9 here has plus, so it's like you say minus times plus, which is minus. All right, so now let's come back here. So now this will be 6 I minus 2i will give us 4i. Y minus 3j plus 9j. You're owing 3, you have 9. By the time you pay that guy that you're owing 3, you'll be having how many left? You'll be having, when you pay this guy that you're owing 3, you'll be having 6 left. So this will now be plus 6j. Then let's go to k. Now we have plus 2k minus 3k. It's like you saying 2 minus 3. You have 2 and you're owing 3. By the time you pay the guy that you're owing 3, that 2 that you have, you still be owing 1. So this will be minus k. There's no need writing minus 1k. Whenever the coefficient is 1, just write only the variable minus k. We already know that the variable here is 1. So this is your answer to a plus b. That's your answer to a plus b. All right. So it's very important to actually note it this way. Okay, so this is how to go about it. So now let's go to the next one, which is b 2a minus 3b. Now this one, you now have the vector set having a coefficient. All right, a coefficient. So now what do you do here? So you write the coefficient first. So you write 2, then bring this vector set a, which is 6i minus 3j plus 2k, then minus 3 bracket, bring set b, which is minus 2i plus 9j minus 3k. So what you just have to do now is to use this coefficient to open the bracket. Very simple. Before you even do the addition and collecting of like terms, so this will be 2 times 6i will give us 12i. 2 times minus 3 will give us minus 6j. 2 times plus 2 will give us plus 4k. Then you come here, do the same thing. You do the same thing here. So you say minus 3 times minus 2i. Remember, minus times minus is plus, so this will change to plus. 3 times 2 is 6, 6i. Minus 3 times plus 9j. Minus times plus is minus. 3 times 9 is 27. You have 27j. Then we also have minus minus. Minus times minus is plus. 3 times 3, 9. You have 9k. Very simple. All right, very simple. So what we just have to do now is to, at this point we have been able to open the brackets with the coefficients. So what we just have to do now is to collect our like terms. So remember how we did in this one, we'll do the same thing here. So we have 12i, okay, plus 6i. This will give us 12 plus 6 is 18. 18i, not 18i squared. You're not multiplying the I by the I, you are adding and subtracting. Whenever you're doing addition and subtraction of variables, it is only the coefficient that will be affected. Then now minus 6j minus 27j. These are like terms. Okay. So minus 6 minus 27 will give you minus 33j. Then the last but not the least, we have 4k plus 9k. 4 plus 9 will give you, I think, 13. 4 plus 9 is 13, so we have plus 13k. So this is, of course, the answer. All right. So I want you to try the C. We have minus 4a minus b. This minus 4a minus b, not plus b. Minus b, please. Why this 2a plus 3b? So try this two. Okay, try this two, and of course send your answers to of course my WhatsApp number is 08140906243. All right, send it on WhatsApp. Show working, please. Show working, please. All right, so send, so I can actually confirm that you have done the right thing. So that's all for addition and subtraction. Okay, if you also want more exercises, more complex exercises, remember there's a minus here. So minus 4a minus b, 2a plus 3b. If you've not subscribed to this channel, do well, like I said, to hit the subscribe button and subscribe to the channel. All right, so in the next video we are going to be looking at vector products, which is, of course, like I said, multiplication of vectors. Thank you. You can like the video. If you have any question, feel free to ask your questions in the comment box below. Bye bye.